Hello guys, so welcome back to my YouTube channel. In this video, I'm going to find the general solution of this differential equation around x equals 0, right? So let's consider x equals 0. uh, let's say the differential equation is in this type. P1y dash plus P2y plus this is equals to 0. So when I write p naught 0, when I substitute x equals 0 to p naught function, if this is not equals to 0, then x equals 0 is a ordinary point, right? This is a ordinary point. If p naught 0 equals to 0, then I can say x equals 0 is a singular point. There are some types of singular points, but here p naught is 1, right? Here this is 1. When I substitute x equals 0 to 1, it is also 1, right? So this is not equals to 0, so x equals 0 is a ordinary point, right? I hope you got it right. Okay, so I will write that again. Y double dash plus xy dash plus y equals to 0. Now since x equals 0 is a ordinary point, I can assume, right? Assume y equals sigma k from 0 to, let's say, n from 0 to infinity. This is an x to the power n, right? So I'm going to assume this, so I can differentiate this one. Y dash equals to n from 0 to infinity n x to the power n minus 1. I'm going to differentiate this again, so this is n from 0 to infinity n minus 1 x to the power n minus 2, right? Okay, so now I'm going to substitute each series to the equation, right? So y double dash, which is n from 0 to infinity n minus 1 x to the power n minus 2 plus x times n from 0 to infinity n x to the power n minus 1 plus what? Sigma n from 0 to infinity an xn equals to 0, right? Now I can multiply x by here, so when I simplify that one, n from 0 to infinity n minus 1 an x to the power n minus 2 plus sigma n from 0 to infinity an x to the power n, here there is a n, plus sigma n from 0 to infinity an xn, right? This is also xn, right? This is also xn, right? So I can simplify it further. So this is from n from 0 to infinity n minus 1 an x n minus 2 plus sigma n from 0 to infinity n plus 1 an x to the power n, right? Yeah, equals 0. Now I am going to take the x to the k power, right? I am going to consider x to the k power. So this is what I need, x to the k, right? So if I need x to the k, this need to be k, right? So then n need to be k plus 2, right? So this is k plus 2 k plus 1 a k plus 2 plus I need x to the k power, so n is k, right? So this is k plus 1 a to the k equals 0. So a to the k plus 2 equals minus k plus 1 over k plus 1 k plus 2 times a to the a k plus 2, right? So k plus 1 cancels out, so sorry, this is ak, right? This is ak, so ak plus 2 equals to minus 1 over k plus 2 times ak, right? Okay, so let's substitute k equals to 0. K equals 0, so a2 equals to minus 1 over 2 a naught, right? Yeah, so when k equals to 1, a3 equals to minus 1 over 3 a1, right? When k equals to 2, it is a4, which is equals to minus 1 over 3 times a2. I know a2 is this, so this equals to a naught over 6, right? When k equals to 3, when k equals to 3, this is k equals to 3, it is a5 equals to 1 minus 1 over 5 a3, right? a3 is minus 1 over 3a, so this is 1 over 15 a1, right? Similarly, I can write this as a5 k equals to 4. I think this is sufficient, right? Okay, let's write the series now. I know a naught from about 3 and a1 also from 3 steps. Okay, so let's write the series. So general solution, right? General solution, y is from sigma n from 0 to infinity a n x n, right? Let's expand this one. A naught plus a1 x plus a2 x square plus a3 x cube plus a4 x4 plus a5 x5 plus and so on, right? So I know a naught is a naught plus a1 is a1 plus I found that a2 is minus 1 over 2 a naught x square plus a3 is minus 1 over 3 a1 x cube plus a4 is a naught over 6 x4 plus a5 is 1 over 15 a1 x to the 5 plus and so on. This is a naught, this is a naught, this is a naught. Okay, so this is a1 right? So even terms are a naught and odd terms are a1, right? So I can take a naught out, so 1 plus 1 minus x square over 2 plus x4 over 6 plus and so on plus a1 x minus x cube over 3 plus x5 over 15 plus and so on, right? Okay, so y equals to a naught y1, let's say this is y1 plus a1 y2, here this is y2, right? This is the general solution. Here a0 and a1 are real constants, right? So this is the general solution. I have solved this one, right? Okay, so if you guys have any questions, please comment below. Thank you for watching.